let's come back to what we were doing. We were developing a AI strategy. We did 3 live streams already on AI. The first one was more like introduction of understanding what are the types of problems that we can solve or how we can manage this task. Then we structure a few notebooks. The idea of today is to review a little bit what we have been done and now how we can put this into something that can be in production. Having something that collects the data for us, runs the transformations, the scatter, we can train different models, we can run optimization, and then we can pick what models we would like to be serving and start serving the models. That's a lot, so probably some of those things are going to be work for home, but I will give the basic guidelines on how to do it. So well, the first thing that I think that we should be doing here is that we were putting the predictions on a topic with the prefix of the HBot, because remember that the first time that we tried to do this, we weren't able to receive the signals from the HBot. So the problem was that when we created this controller, the PMMML, this one, PMMML, here, when we were initializing this, the topic factory for the ML signals, these ML signals was using the prefix of the bot. It's something that we are using in this case. We are putting in this case here to start like streaming the signals. So use bot prefix equal to true. We have another idea or another solution would be use bot prefix false. So in that case, we don't need to pass this. We are going to be getting the data from ML signals. But let me open in Cursor because we can talk with Cursor and ask a few more questions about it. In this case, before going to Cursor, let me make a diagram of what we are going to do. Download Candles notebook, feature engineering notebook, modeling notebook, then prediction service. This is something that we are going to be checking if it's the best thing for this type of service to publish on a topic or not. Maybe we should be triggering an event, because if multiple instances are listening to the signals, we will probably want to let all of them consume the same event. Then adapted Hummingbot to listen to the broker to stream signals through the broker. This is a high level what we did, right? The idea was to end up in this type of architecture where we have the ML server that is right now Quant's Lab. We have different data sources. We can apply different pipelines, and then we can produce signals that we send through MQTT, and the different HBots instances are going to be listening to them. So we're going to, first of all, research if we should be using topic or events. This is what I mentioned before. I think that we should be using events because I think that how it works in the MQTT protocol is that when, or in a broker style, is like if we are using topics, when we send a message to a topic, the first consumer that gets the message removes the message from that topic. So it's like when a message is something that it is not multiplied and accessible for all the consumers. Instead, if you are using an event, all the consumers that are subscribed to that event will receive that signal. That's probably what we want in our case when we are like generating signals from a service, is that we can generate a bunch of signals. If a Hummingbot instance starts listening to that event, can access all the different signals that are out there. So the first is this for signals, adapt the code, and remove the prefix of the bot. Remember what I just told, that here, when we were sending the prediction loop, we were publishing to this because last week, we don't know exactly how this was done, because it was done by a community member. So then I figured out that when we were listening to the topic factory, we were using the bot. As I didn't enter here, and I can just put use bot prefix false, we can just do this and put use bot prefix false, and it will work either way. But well, that will depend on if we are going to be doing the events or the topics. Then we have to research for the events. Then what we need to do is to set up automated data collection for candles. This is only for training models. Why we need this is like, remember that when we built the first model that was like a very dummy model, we were getting the candles of 3 days, I think, in 1 second. And based on the 1 second candles of 3 days, we were processing the data, creating the scalar, and then training a model. So the access to the data should be the same, because we're going to be using 1 second candles for all of the models that we are going to train. So probably the best way will be having a process that we can run a task in Quantsav, that every X amount of time, let's say we can do it every 5 minutes, the task gets executed and streams all the candles in 1 second for the pair that we are interested. So that will let us have an updated data set of the data that we need from the candles to do the next steps, that is like pre-processing the data and then running the models. Then we need to set up automated task for feature engineering plus modeling. What I think that will be the best here is to, in the same task, is like we're going to get the candles that are available right now in the database. Once we have the candles in the database available, we're going to get the candles, pre-process the candles, and probably put them in a, I don't know if in a parquet, or we are going to do it in the same database, in a table that is like processed features, something like that. And we leave that data available, and then we start the modeling process. Then we can do 2 things. One will be setting up MLflow to start tracking, or we can just use Optuna, because I think that using Optuna will be the best, because we already have the integration with Optuna. So we can run the optimization there to find the best parameters for the model. So this process can run, let's say, every 12 hours. So this can be every 10 minutes we collect all the data, and here every 12 hours we run this process of feature engineering and modeling. What this is going to do, we should have another process that will be in charge of promoting the models, but this process should be leaving the new scalar out there and the new pickle of the model trained. So we are going to end up producing a lot of observations, a lot of new models and scalars. Well, scalars is going to be just one, because the feature engineering pipeline will run once. And once we do and with the modeling, we should decide how to promote the models and leave a few models open up there, producing signals. This process will be run every 12 hours. So every 12 hours, we're going to have like new candidates of models. The coolest thing will be after 12 hours, if we have new candidates that are better than the previous ones, start doing predictions with those new models. This is probably a very good design, but imagine that we can have the topic, the broker events. We can have like we said before that the signal was going to be ID market. So well, this can be ID of the signal, and we can also add model ID, let's say model ID, something like that. But we can have a channel. This can be here. This can be ML signals, and we can also have ML signals staging, let's say. And we can have like two different channels. So if a new model comes and is good, we can test it in a staging environment. So we have a few instances, or the same instance that is running in Hummingbot, obviously. But when the signal comes from staging, so these are the new models that were promoted, we can use those signals, but with less amount, let's say. That can be also something cool. But well, for now we're going to give it stick with a simple example. These are some ideas that you can start implementing in the future. Then we need to clean up the prediction service, supporting multiple models, STD signal generation. And in the Hummingbot side, create simple directional strategy for ML signals. So this will be the other thing. Will be like, let's create us a simple directional strategy, because the other day what I did with this one is like this strategy that we were doing PMM ML was modifying this strategy that is one that I'm running for market making, that basically prevents trading on a market make on a side where, let's say that the signal says long, we were preventing placing short orders. Well, the idea will be, instead of having this strategy, I'm going to show how we can create a custom directional trading controller, so we can stream the machine learning signals, and then we can start trading directional with that. We can probably put, instead of just placing the signal, we can place a grid. That will be also something cool. And we also need to create YAML. Okay, so it's time to start. So first of all, we need to set up the automated data collection for candles. So let's go to Quantslab. In the Docker Compose DB, here we have this timescale DB started. We have the timescale DB running. We are using timescale because it's like optimized for time series. It's like a Postgres, but more oriented to time series. So we have the database there, and now we need to run the create a task, candles downloader task. Let me review. So we have connector name, perfect. Days data retention. Here we are using like 7 days. I think that it can be interesting to do it for 7 days for this problem. Intervals is a list. We're going to configure it later on, so don't worry about it. Then quote asset is USDT. Okay, this task downloads all the candles that are available. Let me create a new one, call it simple candles downloader, because this task is to download like all the markets that are available there. But here we want to just download trading pairs. Let's put BTC USDT. And this mean national size, we don't need it. This is the execute method. It's like, this is good because I'm going to teach you how the task works, or simple context loader. So let me explain how it works. Here you have the execute method. This execute method, what it does is to execute an async task. This is not something fancy. But what is important is that see that this base task, the init has this name, frequency, and a config. The frequency is like the frequency where this execute method will be called. We are going to call the execute method every X amount of time. In this case, it's like, as you can see here, the frequency is every hour. So what we're doing here is every hour we're going to be calling the execute method. If we run this execute as it is, as you can see here, this will be just run once. But once we put this into the task, it will be using the other process. If you want to see how that is done, it's very simple. I just added a line. It's called task orchestrator, adds a bunch of tasks, and the run just run with a frequency, a core routine for the task. So they are really independent, and there is a loop. Because the base task has this method that is run with frequency. We check the last run and all the stuff. Here, the execute method, that is the one that we are going to be running. Standard scanners downloader for, this is the same, so we can just remove this. Quote asset, this is going to be trading pairs. We have to do login info, trading pairs. We don't need that. This time scale, I think that we can add this client here. Self.timescale client is going to be here, and then on any execute we connect to the timescale and just run it. Trading rules, we don't need the trading rules. Trading pairs, we don't need the trading pairs. We just need this self.trading pair, and this is self.trading pairs. There are a few methods that should not be here. So table name, we're going to get a table name based on the connector name, trading pair, and interval. Then we are going to create the candles table. So this is just creating, if it does not exist, the candles table for it. Then says get last candles timestamp. This is cool because we're going to be requesting via REST the candles from this timestamp. And then says start time, candles timestamp, candles, get candles from using the cloud for a trading pair, no new trades, append candles, no new candles in case of the data is empty, self.timescale client. Okay, and this is, here we are appending the candles to the table, and here with the cutoff, what we're doing is removing the candles based on the retention policy that we defined before. That is like, we want to only have 7 days. Let's try it as it is. Intervals, let's put like 7 days in 15 minutes. Days data retention, let's put 7 days. This, we don't need that. Quote asset, we don't need it. And we need just put here trading pairs, this. Okay, so if we run this, do we have the database connected? Database, let me connect to the database name, quants lab, localhost, user, admin, database, timescale. Let me test the connection. Okay, we are connected. So this quants lab TS, we have here public. There is no tables yet. Let's run it. the best way to debug a task is to do it in the same file. As you can see, I always add this main, if name equal main, tables, one table, Binance 15 minutes, okay. So as you can see, we have a new table that is Binance Perpetual BTC USDT 15 minutes. We are downloading the candles properly, and we are storing those candles in our database that is here. Let me drop this table. Now let's see how we can run this in a container and create a config for it. So to create a config for it, this is a live stream task. This was for another one, so yeah, let me copy and paste, and let's call it candles download or AI live stream .yaml. So how this works, I will push this YAML config. So let's call it candles downloader. So how it works is like we need to go here, is data collection, simple candles downloader. So this is this file, and then the class is called simple candles downloader. So this is how we reference, this is the file or the task that we need to run. Then we need, enable equal to true. This is because with a false here, probably we can just stop it. And then is the frequency in hours. 0.02 times 60 is every 1.2 minutes, I think. So this will be running every 1.2 minutes. And here we need to pass a config. As you can see, I don't need to pass the timescale client unless that we want to have a custom one. But as you can see, this base task runner has a get common config that by default has these values and already puts the timescale config here. But if you want to change it and put another config in the environment, you can just put these values of timescale host, timescale port, timescale user, and password as environment variables, and that will work too. As I'm doing it locally, and usually you are going to do it locally, you're going to run this process in the same place that you have the DB, doesn't care. And now for the config, what we need to pass is these things. So let me copy here this stuff. This config was for the other live stream that we were doing, like scrapping of pools in the blockchain. So I think that we don't need this. We just need to do this. I think that the YAML works 15 minutes, days data retention, and trading pairs, BTC USDT. This is the config that we are going to use to run the process every 1.2 minutes. So now, if we go to the terminal, and the way to really run this is using the make file. So just to summarize all the steps and you don't get lost, is like we coded this base task. This base task is to download the candles of the trading pairs that we want in the intervals that we want with a certain frequency. And then to trigger that task, we need to create this YAML that has the name of the process that we are running, the class that we're going to be executed, the frequency that we want, and the configuration for that task. This is very handy because probably just to explain how you can use tasks is that you can have this task to collect candles. You can have another task to generate a report. You can have another task to send notifications. So there are a bunch of different tasks that you can have, and you always want to have some automated things running in the background to do this. There are other ways to do it. Instead of using this, you can just use Daxter or Airflow or Prefect. There are a bunch of orchestration frameworks. Here I decided to keep it simple and just code a simple orchestration that just executes a method over time. But well, you can do it whatever you want. So in order to run it, if you check the make file, you will see that in the main file you have this run task, right? So with this run task command, what it does is like we can specify the YAML that we want, and that will let us trigger that into a container. The way to run this is to run make. As you can see, this is a make file, and also check that here says config equal to config. So what we need to do, this is going to search for the parameter config to put it there. So what you're going to do is to put make run task and then put config equal to the name of this config, that is AI livestream.yaml, AI livestream.yaml. If we press enter, instead of tax is task. So as you can see, it started. Okay, now we have the first error that says key error timestamp. Okay, I know what it happens. It's a common problem that we have. Let me create a club here. There is a change that we have to do in the club, but I think that like this we can solve it. Okay, let's try it again. So we are downloading the candles, perfect. And now there is a problem here. Maybe the best way to debug this is going to be from source. So let me do this. Await async IO sleep 1. So let's go up to this point. And let's run this so we can understand why we're having this issue. We are still having the issue here because, so here we pass up to this point. So we are here, missing records, fetch candles. There is a problem with the candles. This can be something to check for my friend Drupman, because the problem is that we are downloading the 15-minute candles. So as we already downloaded some candles in the database, and when we are requesting the newer candles, they just return one record, that is this value. We are not adding the columns for the candles, so this is just a numpy array. So the solution here, I think, that is doing this. I think that solves. Let me try again now. But I think that there is this was a problem from the candles. No, we are still, a non-type has no attribute candles. Yeah, the problem is that there is no candles here. Candles df is none. Well, in fact, this is something that we should do it more carefully, because this is a change that we should be addressing properly, not in a live stream without thinking. That can be a potential problem. But at least we are not having this issue anymore with those changes. But it's something that we need to do. So the change in the candles, I would tell my friend that he has to fix this. But for now, what I will do in order to avoid having this issue or needing to modify the code is like, let's put try and accept here on this method. This would be key error, I think, and this would be error fetching candles for this, and continue. Okay, well, this is going to be some quick fix for this. Well, in terms of the config, this is AI live stream. We were saying we have these intervals 15 and 1 minute. Let me remove again these tables and let's start over to see that now the Docker is also working properly. Let me remove this. Let me drop this table and let me drop this table too. Perfect. So let's go back to here and let's run the task again. So one thing that I didn't mention is that to run this in Docker, you need to build QuantsLab locally. That would be docker build -t whatever. With that, you can start using the QuantsLab as the image of the QuantsLab to run these tasks in Docker directly. If you check here in my Docker desktop, I have the QuantsLab project, let's say, and we have this timescale DB that is the one that we are running to store the data, and we have this task runner that is basically the process that we are running right now. Perfect. Like 15 minutes is failing still for the same thing, but we are continuing. It's not stopping or blocking because we did a try except here in the simple Canvas downloader. We added the except key error. That is the error that we are handling. Error fetching candles for Binance 15 minutes, key error timestamp. So perfect. Everything is working properly. So now that we validated that with 15 minutes works properly, let me stop this as it is and let me remove the tables that we just downloaded and let me run it with detach mode. Okay, perfect. Let me put 1 second because we were doing 1 second candles. So let's put 1 second here. So let's run task D, run task D, detach it, and let's add this. Okay, so now let's put dash D and let's start running. Well, now we completed the first one, that is setting up the data collection for the candles. Is in 1 second, so really cool. So this is done. Now we need to set up an automated task for feature engineering and modeling. Basically, what we need to do is to move this feature engineering notebook to a task. So first of all, before moving this feature engineering notebook to a task, we need to think that we actually need the information from the timescale DB. That before we were getting the information from the now we have a few. Well, at the end it's going to be append all the traits at once. But before we had the information, we were getting the information through the Parquet file. So now we need to connect with the database. So let's create a new task here that is going to be, let's call it data collection. No, let's call it feature engineering. So new directory, feature engineering, and let's add a new Python file. Well, let's copy the simple canvas downloader because let's go Bitcoinator was, how was the name? Bitcoinator. We said that we're going to do the feature engineering and the modeling task together. So here let's call it this like Bitcoin. Let's, instead of feature engineering, let's call this ML pipelines. This would be Bitcoin base task. Connector name, we don't need this. Instead of days of data retention, let's call it like days for training. So we can specify as get the last 3 days from the data from trading, or get the last 5 days, or whatever. We can have different pipelines of this. Let's use 3 or 7. The intervals that we would like to do here is just one interval. This will be config get interval, and let's put 1 second. Trading pair. Remember that we are just doing this for one pair with the Bitcoininator. So BTC USDT. Timescale client is the same thing. And now we need to work on the execute part, where we need to get the candles from the timescale DB. We need to process all the candles. We need to save the scalar, and save the model later on. Well, so we don't need the club. We need now is starting. Let's call this starting feature starting ML pipeline for this start time. This will be days for training. We're going to connect to the timescale DB, and then instead of looping, candles is equal to await self dot timescale client get candles as days self dot connector name trading pair. So this part we don't need. Oh no. Now we need to we have the candles. I would like to check that this works well and I can get the candles. And I also want to know like how fast we can get the candles from the timescale DB, because sometimes, as there are a lot of candles, probably it's a lot of data for one request, and maybe this is slower than just using a Parquet. So that probably for big amount of data will make more sense to do it in a Parquet. But let's try. Let's see if we are doing if we can do it properly or not. Let's see if we have some candles here. We are still downloading candles. We don't have any candles here. Let's see if we have any error on the container. Oh, error, invalid interval. We are having the problem of invalid interval. Okay, invalid interval because we are using Binance Perpetua instead of Binance. Let's run it again. In the meanwhile, assuming that those candles work well, let's continue with the pipeline. So the things that we need to do here is, first of all, apply this triple barrier method, put in the side. So let's start with that. Let's also add the import here. These candles is a DF. The return of this is, so let's put here DF is equal to candles data. Then we apply the triple barrier method. Here we can extract this into different variables. So we can run like, we can say like self.target multiplier. is equal to config that target multiplier, let's put 3, and let's use this as target multiplier. Then we have time limit self dot tl is equal to config that get tl, and let's put 300. This was like 5 minutes. So self.tl, then we have self.std span config that get std span, let's use 200 as is on here. This is something that you can also do with your with a base model instead of a dict here to make this config a little bit more fancier, but and enforce like the types. But for now I just use a dict just to simplify. And then we have the trade cost, self.trade cost. This is in this case I'm using 0 because I'm analyzing for Bitcoin. Let's see how it's right now. 87. We are not okay, but I'm analyzing for Bitcoin, so in this case it's like I don't care too much about the trade cost because I'm using this FDUSD that has 0 fees, this market. That's why I am able to trade in this style. So here config that get trade cost, let's put 0. Well, the first part, that is adding this triple method, is done. Then we need to run this part. Let's import the standard scalar. Let's import the pandas TA. And then we can apply all the indicators. Just let's copy this as it's done here. Let's put it like it's all synchronous, right? Yeah. Def add features. Let's return the scalar and the df. Okay, we don't need this, we don't need this. Perfect. This method might be static, as we say. And we can dump the features df and the scalar. These are the two things that we were doing. But as we are going to be continuing the pipeline, this was more for understanding what to load this in another notebook. We don't need to dump this. The only thing that we need to dump is a pickle, but we can do this later on, since we don't need to. We are going to train a bunch of models and we can do it at the end. Just understand a little bit how this makefile works. Is a Docker Compose as runner, and it has mapped quanzab config. So yeah, so it's all mapped. So we should be able to get access to the data folder to store our models, the models folder to store the pickle. Now that we have the df processed, we need to apply the indicators. The model. We need to train the model. Actually, this is a very dummy thing because we are not doing cross validation. We are just splitting between the train test split and not doing anything that can benefit our model. Let me first see if the candles are downloaded. Yeah, we have candles. So let's see if we can get the candles here and do the first step, that is doing the processing properly. So let's run this. I don't know why it says 1 second and it says also Binance. Yeah, it didn't update this interval. 1 second. Days for trading, I call it this. Let's put 3 days. Trading pair BTC USDT. So let's see if I can connect now. I can get the table. Okay, now I have the candles here. They are ordered properly. Apply the 3-bar method. This might take a while. Just to summarize what we have been done, because we are like live for 1 hour and a half already. In 1 hour and a half, we discussed what we did before, all that stuff. We set it up, the automated data collection for candles. Seems like it's working. Fetching candles, fetching candles, fetching candles. So it's like we are still downloading all the candles and they are getting updated into the database. We have that process in an automated task that I will upload also the config for it. And now we are here. We move all the scaling part to to another task. This is the second task that we are working on that will be running every 12 hours. As you can see, we already added the 3-bar method here. Add features is missing one positional argument, df. I did it a static method and I didn't remove the self. Unfortunately, we need to rerun it because I was using the self here. I shouldn't, so let me add a few logins here. Login, info, starting, login info, mega page, adding features. So, well, it seems like a equal to, so we put a breakpoint here and we see what we have. Well, so we get the candles from we have a process that is populating the database. That database will give us the candles. We are going to apply the 3-bar method to those candles. Once we apply the 3-bar method, we're going to add the features. Once we add the features, now we need to train a model. As I mentioned, the modeling that we did is very simple. Doesn't make too much sense because it's just testing one parameter, one set of parameters, and we'll probably, instead of just splitting between train and test, we would like to do something a little bit more custom that can be like doing a cross validation. Actually, in the Marcos Lopez de Prado book, he recommends a technique that is called purge and embargo to separate the training and the test with a slot of time where there is no like intervention, where we assume that the data that we use for training is not affecting the data that we're using for prediction. So we say he leaves like a blank, or not a blank, a time frame, a small time frame without we separates with a time frame between the training and the testing. The thing now is, should we use Obtuna, that is something that we already have integrated, or should we use something like MLflow? Maybe we can use MLflow because I think that it let us dump the artifacts here too. So I can just tell Cursor about this. I'm working on this automated task to train a ML model. I want to use MLflow to do experiment tracking, and also I want to do cross validation, and I think that is worth to do it. Also, I want to store the scalar and the model. Can you help me adding the service of ML flow into a new Docker compose ml.yaml to train the model and store the results in MLflow. Okay, let's see what Cursor can do with this prompt. Let's see what changes we have here. So it seems like this MLflow by default has this S3 to store the artifacts, and here we are like replacing the S3 with this mini-o that seems like it's open source. Let me run this ML, the Docker compose.yaml. Let me run this and see if everything works. Depends on timescale DB. Yeah, maybe that's a better option. Like, no, let's stop and reject. Instead of doing this, I will say do not depend on this timescale DB. I will say when trying to run Docker compose that's a new one in chat. There's ML. I'm having issues with finding timescale DB. Can you fix them? Now that Claude can run code and see the errors and all that stuff, it's really cool. Don't do that. The DB is already if this works as it is, it's fucking crazy. Then I will say to Cursor that this prediction service, it's called prediction service MLflow. Now please adapt this prediction service MLflow to use the models. Let's see what it does. Oh, okay, we have a problem here. Network Docker compose DB default declares external but could not be found. I think that the name of the network is not that. The name of the network is, let's see, Docker desktop, or is it here? The network. Network Quants Lab default is called. Uh, 5000 is available. Let's do 5001. No module name Psycho PC2, but I will say that I'm having that error when running the services. Yeah, maybe it was not a good idea to start with this MLflow as it is. Maybe this requires a little bit of more work from my side. before and just telling you this is the final solution, because I never use MLflow, so I don't know what's the best way to deploy this. So maybe what we can do is let's see what are the missing tasks. This one is like if we remove the part of MLflow and we just run and train the model in a consistent way, we can have this ready very fast. But I really think that having experiment tracking and being able to run multiple experiments will be something that will let us scale later on. So probably we can stop here with the development. We have like almost this task done. Then the half of this task is done, like create YAML for data collection. This is done. And for automated training, this is also like done. No, this is not done, but it's going to be very simple because we can use the same YAML. Then we need to clean up the prediction service. That is what we were doing in the meanwhile. So it's like half done. And the simple election strategy. So was very optimistic to finish this in a live stream in 1.5 hours. But well, probably what we can do is I will do the work of researching how to really set up the MLflow to have the experiment tracking of all these models. So then you can tweak a few parameters, run experiments, and all that stuff. Let's continue next week on this. If you have any ideas or if you have experience deploying MLflow before, or another solution is like I'm not stick to MLflow, I never used it before. See you next week, guys. Let's keep it up and continue working on this. Bye bye.